ever wondered what it takes to build a home on Mars or the Moon? The answer might lie in 3D-printed habitat solutions for space colonization, a groundbreaking technology that could change the future of human life beyond Earth. Imagine a giant 3D printer, but instead of printing small plastic objects, it prints entire structures suitable for human habitation in the harsh environments of space. This is no longer science fiction. It is a reality we are rapidly approaching thanks to advancements in technology and innovation in space exploration. Welcome to this journey where we will explore every facet of 3D-printed habitat solutions for space colonization. But before we delve deeper, make sure to subscribe to our channel and hit the notification bell so you never miss out on the latest and futuristic technology. Now, let's uncover the incredible world of 3D-printed habitats. The concept of 3D-printed habitats is as fascinating as it is complex. At its core, it involves using a 3D printer to construct buildings and other structures layer by layer. This technology has already been utilized on Earth for creating houses, bridges, and even intricate art pieces. Yet, the potential applications extend far beyond our planet. In space, traditional building methods are not feasible due to the lack of natural resources, extreme temperatures, and the absence of a stable atmosphere. This is where 3D printing comes into play, offering a solution that can utilize local materials, minimize the need for transporting bulky construction materials from Earth, and create habitats that can withstand the challenging conditions of space. To understand how 3D printed habitats can revolutionize space colonization, we first need to delve into the mechanics of 3D printing itself. The process involves creating a digital model of the desired structure, which is then sliced into thin layers by specialized software. The 3D printer reads these layers and begins to deposit material, layer by layer, to create the physical object. The materials used can vary widely, from plastics and metals to innovative substances like regolith, which is the loose material covering solid rock in bodies such as the Moon and Mars. By using local materials, known as in-situ resource utilization, 3D printing can significantly reduce the payload weight and cost of space mission. In the context of space colonization, several organizations and companies have been spearheading research and development in 3D printed habitat. NASA has been a frontrunner in this field, launching initiatives such as the NASA 3D Printed Habitat Challenge. This competition has encouraged teams from around the world to develop innovative architectural concepts using 3D printing technology that could be used on Mars. One notable example from this challenge is Marsha, a vertical egg-shaped habitat designed by AI SpaceFactory. This design leverages the natural properties of Martian soil to create a strong and durable structure, addressing issues like radiation protection and thermal insulation. Another significant player is the European Space Agency, which has been exploring the feasibility of using lunar regolith for construction purposes. The ESA's goal is to create sustainable habitats on the Moon that can support long-term missions and potentially act as a stepping stone for further space exploration. They've demonstrated that simulated lunar soil can be used in 3D printing to construct robust structures, which could one day house astronauts on the Moon. Private companies are also making strides in this area. Icon, an American construction technologies company, has partnered with NASA to develop Project Olympus, which aims to create a space-based construction system for building infrastructure on the Moon. Icon's technology has already been used to build homes on Earth, proving its potential for creating sustainable and cost-effective living spaces in space. Let's take a moment to visualize what a 3D printed habitat on Mars might look like. Imagine landing on the red planet and seeing a cluster of dome-shaped buildings, each created by a massive 3D printer using Martian soil. These habitats would be designed to protect inhabitants from the planet's harsh conditions, such as extreme cold, intense radiation, and frequent dust storms. Inside, they would be outfitted with everything necessary for a comfortable and functional living environment, including sleeping quarters, laboratories, and communal areas. The walls of these structures could even incorporate layers of different materials to provide insulation, radiation shielding, and structural integrity. One of the most significant advantages of 3D printed habitats is their adaptability. Traditional building methods require precise planning and execution, with little room for modification once construction has begun. However, 3D printing allows for greater flexibility. If a particular design proves unsuitable for the environment, or if unforeseen challenges arise, the digital model can be quickly adjusted, and the new design can be printed without the need for starting from scratch. This adaptability is crucial for space exploration, where conditions are unpredictable, and the ability to quickly respond to new information can make the difference between success and failure. Safety is another critical aspect that 3D-printed habitats address effectively. Space is an inherently dangerous environment, with risks such as meteorite impacts, radiation exposure, and the absence of a breathable atmosphere. Traditional construction materials and methods may not provide adequate protection against these hazards. However, researchers can design 3D-printed structures with these challenges in mind, incorporating materials and architectural features that enhance safety. For example, multi-layered walls can be designed to absorb and deflect radiation, while the shape and layout of the habitat can minimize the risk of damage from meteorites. The environmental benefits of 3D-printed habitats are also noteworthy. Transporting building materials from Earth to space is prohibitively expensive and resource-intensive. By using local materials like lunar regolith or Martian soil, space missions can significantly reduce their ecological footprint. This approach aligns with the principles of sustainability and in-situ resource utilization, promoting a more environmentally friendly method of space colonization. Moreover, the innovation and research around 3D-printed habitats have ripple effects on Earth as well. The technologies developed for space can be adapted for use in remote or disaster-stricken areas, providing quick and cost-effective housing solutions. For instance, areas affected by natural disasters often face significant challenges in rebuilding infrastructure. Using 3D printing, emergency shelters can be constructed rapidly and efficiently, providing immediate relief to those in need. As we look to the future, the possibilities for 3D-printed habitats in space are virtually limitless. Beyond Mars and the Moon, this technology could be adapted for other celestial bodies. For example, exploring the moons of Jupiter and Saturn, such as Europa and Titan, could become more feasible with the ability to construct habitats using local material. Each of these environments presents unique challenges, but the adaptability of 3D printing technology means that solutions can be tailored to meet specific needs. The advent of 3D printed habitat solutions also opens up new avenues for international collaboration in space exploration. Countries around the world can contribute their expertise and technology, working together to develop sustainable living environments beyond Earth. This collaborative approach not only accelerates technological advancements, but also fosters a spirit of unity and shared purpose in the pursuit of space colonization. In conclusion, 3D-printed habitat solutions for space colonization represent a revolutionary step forward in our quest to inhabit other worlds. This technology offers unparalleled advantages in terms of adaptability, safety, sustainability, and cost-effectiveness. As research and development continue to progress, we move closer to a future where humans can live and thrive on planets like Mars and the Moon. The implications for science, exploration, and even life on Earth are profound, heralding a new era of innovation and discovery. Thank you for joining us on this fascinating journey into the world of 3D-printed habitats for space colonization. If you enjoyed this video, please like it and share it with anyone else who might find it interesting. Do not forget to subscribe to our channel and hit the notification bell so you stay updated with our latest content. We would love to hear your thoughts on this topic, so feel free to leave your comments and questions below. Until next time, keep looking up and dreaming big.